A minute, let me move everything out of the way. Scroll down. Tell me what's positive and what's negative in these four quadrants. How about quadrant 1?
All of them are positive.
Quadrant 2.
Sine is positive.
Sine and what else? You don't really write the other thing, but if...
Or no, secant.
Not secant, cosecant.
Cosecant, right.
Remember, the first letter is always different with their reciprocals. How about the third quadrant?
Tangent's positive.
And cotangent. In other words, if the tangent's positive, then the reciprocal has to be positive also. And in the fourth quadrant, it's cosine and secant. Notice the C and the S. You never have a C together with a C or an S with an S. All right, now let's look at their picture. Where is that true?
Everywhere but quadrant 2.
Everywhere but 1 and 2. So that's 3 and 4, right?
Yeah.
You see why? In other words, the sine, everything's positive in the first. And the sine is positive in the second, which means the cosecant is also positive. So if the cosecant's negative, it's got to be in the third or the fourth. Now, tell me where tangent is positive, this part of it. Which two quadrants?
1 and 3.
So what's the answer?
3.
Uh-huh. In other words, that is the only quadrant where both of those are true. There's two ways to look at these problems. You can look at it as the unit circle, and it's in quadrant 2, so I know it's got to be some sort of angle like that, and it makes you can go through it with the unit circle analysis, but I actually find that makes it more complicated. I prefer to do my technique that I tell everybody to do. When they give you a trig function and they tell you what quadrant it's in, then first step is always what? Always. You don't draw the unit circle. What do you do?
Check the sign.
You draw a triangle. And you label the angle that they're talking about. Well, this is the angle A. And you draw a right triangle. Now, dimension that right triangle based on this only. Forget this for a moment. Forget the quadrant 2. Just rest that aside. Okay? Set that aside. You don't need it yet. Dimension the triangle as much as you can based on that information. The secant of A is 5/4. It allows you to give me two sides of this triangle. Which two are they? Forget the sign. I don't even care that it's negative 5/4. I just want a triangle where the secant of A would be 5/4.
So it'd give you the adjacent and the hypotenuse.
Okay, so which one is which?
4 is the hypotenuse. Or no,
Hypotenuse is
5.
always the longest side on any triangle. Always.
5 is the
On a
hypotenuse.
right triangle that the hypotenuse is not the longest side on. So that has to be 5, that has to be 4. Remember, the secant is the reciprocal of the cosine. Cosine is adjacent over hypotenuse, so secant must be hypotenuse over adjacent. Now, that allows us to dimension the third side of this triangle. What is the third side?
3.
And we can do it basically using Pythagorean Theorem, but when you recognize a 3, 4, 5 triangle, you don't have to go through the Pythagorean Theorem. You can just do it. Now, what's the tangent of A? It's the absolute number.
The 3/4. So A.
Now, let's go back and see, we're in quadrant 2. Well, what is tangent in quadrant 2? Is it positive or negative?
Negative.
There's your answer. Notice that I did not pay any attention to the quadrant or the sign, that little sign right there, until the very end. In fact, I didn't even care the negative sign in front of the 5/4. That never came into play. Once they tell me it's in quadrant 2, well, then I know what the sign on tangent's got to be. That's the only thing I care about, is what the sign on tangent is. Always remember that. When they give you one trig function and they ask you about another trig function, first step, always draw that triangle and label the angle. And go through that exact process. It never changes. Give me a trig function that fits number 12. Starting with
Tangent.
Trig function.
Tangent.
Of an argument, an angle. Tangent what?
Z.
Equals, and then an equal sign. That's the way they all start out. Not always tangent, sometimes sine or cosine, depending on the two sides that you know. So what's it equal to here?
4/3.
Now, how do you find z? By definition, if tangent of z is equal to 4/3, what is z equal to?
Inverse tan of 4/3.
Pull your calculator out. Give me a number, round it off to one decimal place. Pick an answer.
0.927.
You got it in radian mode.
Yeah.
Now, you got the inspire, right? What are you using today?
The inspire.
The only weakness on the inspire that I have found that I don't like about it is the fact that it's difficult to change from degrees to radians. It's not obvious at all. If you don't know how to do it, it's really hard to figure it out. I think you got to go to Documents, Settings, go down to where it says radians or degrees and switch it. Now, before you do that, let's just make sure I'm right. Type in the sine of 30. What do you get?
Sine of 30?
Yeah, we know that's 1/2. So if it comes out 1/2, you're in degree mode.
Well, what I usually do is I usually put sine 30 and then I add the degree sign.
Don't do that. Just put sine of 30. What I'm trying to do is figure out what it's in.
If I'm just sine 30, yeah, it's in radian mode.
Okay. Do you know how to switch it?
No.
Here, I think I know how to do it. I just had to figure it out the other day.
Oh, I found it.
What's that?
I think I found it.
Okay. Like I said, I think you got to go to Document, Settings. Tell me if you get it.
Yeah, document settings, angle, degree.
There you go. Now, once you get in degree mode, now do sine of 30.
Yeah, 1/2.
Okay. Now, you see what the problem with doing it the way you were doing it before is when you put in degrees, it'll do degrees, but it won't tell you what your calculator's in. I was trying to figure out what the calculator was in so we would be able to answer this problem. Now that we know that the calculator's in degrees, then do the inverse tan of 4/3 again.
So 53.1.
Right there. Only reason I knew that is I happen to know that 3, 4, 5 is basically 3753. Those are the two angles of a 3, 4, 5 right triangle. All right. Now, why do you suppose they put none of these in there? Why is this in there? To catch
In case you get the wrong
in
one.
radian mode. In other words, everybody has to use a calculator to answer this problem. So anybody that's in radian mode, the first answer you got was 0.91, I think, or something like that. And if that's what your answer is, and you might answer none of these. So it's a trap. They'd been much better, they'd have been much more favorable to not put that in there. And then when you got 0.91, you would be alerted to the fact, you must be in radian mode, not degree mode. So you get a chance to save yourself if they don't put E in there. But when they put E in there, they're getting to trap you. If you're in the wrong mode and don't know it, you're going to answer E. All right, these are kind of interesting problems also. And we're basically, this is hard to explain, but I will try. The way you have to look at this problem is that is some angle, right? Correct? In other words, we take inverse trig functions of angles to get ratios. Excuse me, I got it backwards. No, that is true. Sorry. We take trig functions of angles. We take inverse trig functions of ratios to get an angle. So that has to be an angle. So let's call it an angle. Okay? Now, let's draw our triangle, just like before. Our right triangle. Label X. Not X. Notice that X is not an angle. X is a ratio. So we'll label that theta. We'll call this, instead of angle, we'll label it theta. With me?
Yep.
So, if the inverse tan of X is theta, then dimension this triangle based strictly on that. In other words, X has to be the ratio of the opposite over the adjacent. So dimension this thing. What's the opposite got to be?
What's the opposite going to be?
This is a little hard. Here, let me help. X and 1.
This would be X over 1, so just X.
And I get that strictly from that. In other words, I'm looking for X to be a ratio. Well, it is a ratio. It's X over 1. And the tangent of theta is X over 1. We're looking for the inverse tangent of X. But that gives you this angle theta that I've labeled here. Now finish dimensioning this triangle. In other words, once you get two sides of it, you can always use the Pythagorean to get the third side. What has this got to be? Square root of what?
One plus X, or no?
1 plus X squared. Pythagorean Theorem, the hypotenuse is the square root of the sum of the squares of the sides. Okay?
Okay.
With me? Now we know everything there is to know about that triangle. And they're asking for what is the sine of theta. So what's the sine of theta?
So it'd be X over square root of 1 plus X squared.
Right there, B. Now, this is a little confusing. And the reason it's a little confusing is because it's really easy to get confused about the difference between X and theta. Notice that my entire problem started out by saying this was theta. I know that when I take inverse trig functions of something, I get an angle. This is an angle. I'm going to choose to call it theta. That's a vital first step for solving this problem. You have to do that. And if that angle is theta, then the tangent of theta is X over 1, if it's dimensioned like this. Well, then that makes theta equal to the inverse tan of X over 1. Well, that's what they're telling us. That theta is the inverse tan of X. And since our argument with inverse trig functions is always a ratio, we got to make it X over 1. This problem would have actually been easier if they'd have put x over 2 or something, because then I would have known that was x and this is 2. The fact that they make it x, you have to add the 1 in there. The key being that you take inverse trig functions of ratios. Not numbers, but ratios. All right. Now, the next one's pretty much the same thing. By that I mean we had on that last one we had the trig function of an inverse trig function. Well, this is the same thing. We have a trig function of an inverse trig function. So we're going to take the same strategy. First step.
So this would be 2y. So the angle is 2y.
What's the first step? And this is a very important step. It's to make sure you know that that is an angle. We'll call it theta. It's not y. It's theta. When you take the inverse trig function of something, you get an angle. We don't know what the angle is, but we're going to call it theta. Okay? Now, next step, draw your triangle, label the angle we're talking about. Now, dimension this thing. Remember that the cosine of theta equals 2y. So how can the cosine of theta be equal to 2y? In other words, that's what inverse cosine of 2y equals theta means. When I write this theta down there, what I'm really saying is that the cosine of theta equals 2y. These two things mean the same thing. This is talking about the inverse cosine of 2y. I'm saying that's equal to theta. So theta equals the inverse cosine of 2y. That is all true. Now, that helps us dimension this triangle. If the cosine of theta, right here, is equal to 2y, tell me what this triangle dimensions at. Need that to be a ratio.
So it'd be y over 2. Or no, 2.
About 2y over 1. Which side is 2y? Which side is 1?
Two y is the adjacent side.
Which side is 1?
The hypotenuse.
Now, what's the third side? This is where you have to be really good with the Pythagorean theorem. You don't want to have to solve it from start every time. You want to be able to solve any triangle where they give you, any right triangle where they give you two of the sides. You want to be able to do that quickly. Well,
so it'd be 1,
two of the sides. So what is it?
1 minus 4y squared.
It's the square root of that. Whenever you're solving for a third side of a right triangle, your answer is almost always the square root of something. Almost always. Sometimes it's the square root of 25 and it turns into a number like 5, but it's always the square root of something. Here's our right triangle. That's C, that's A, that's B. We know that C squared equals A squared plus B squared. So C is always the square root of that. Okay? If you're solving for one of the sides, A has to be the square root of C squared minus B squared. And B has to be the square root of C squared minus A squared. Notice that whenever we're solving for A, B, or C, the answer is always square root of something. Always. It may turn into a number, but it starts out as square root of something. So we've got our third side. Now we're in gravy. What is the tangent of theta? Remember, this thing is equal to theta. And my triangle reflects that the cosine of theta is 2y.
So the square root of 1 minus 4y squared over 2y.
Correct.
Should be A.
And that's how you do these. But the critical step really is to understand that that is theta. If you don't do that as a first step, you're never getting to the second step. All right, this is going to require you to have your trig identities memorized. Let's start with 1 over cosine squared of theta. What's that equal to? This right here.
I don't know like any of my trig identities. Shoot.
Zach, I don't know how you're going to go forward. This whole test is about trig. Do they give you a cheat sheet?
No.
How are you going to do this?
Memorize them, I guess.
Well, I can't help you memorize it. I mean, I can try, but I can't do it for you. What's the reciprocal of cosine?
Secant.
Okay, so this thing is secant squared of theta minus 1. That's the first step. Now, let's go back and look at our Pythagorean identities. We've got 3 of them. Sine squared plus cosine squared. What's that equal to?
1.
Tangent squared plus 1 equals 1.
Wait, tangent squared plus 1
equals 1. There's 3 trig identities. You got to know all 3 of them. The only 2 you have to memorize are these 2. I'll give you the third one, but I'll give you an easy way to remember it. But you do have to memorize these 2. That's secant squared. Okay? Now, the third one they want you to know is the cofunctions of the second one. What's the cofunction of tangent?
cotangent.
What's the cofunction of secant? Not the reciprocal, the cofunction.
Cosecant.
That's the third one. In other words, is all you have to do is make the third one exactly like the second one, only substitute their cofunctions. All right? For this problem, we don't need the third one. I just wanted to point it out that the third one's easy to memorize. You don't have to memorize it. Never memorize anything you don't have to. Unfortunately, most of this trig stuff you do have to. Okay? So I'm trying to figure out what that is. If this is true, then tell me what secant squared minus 1 is equal to.
Tangent squared.
how you do it. But you can't do any of it unless you know your reciprocals and your Pythagorean properties. Let's go over them. That's probably the best thing we can do. Let's see if I can help you memorize them. There are 6, let me bring up my page here. So I have a fresh page to draw on. There's 11 that you have to know. 11 trig identities, and this will get you a long way. Okay? There are 6 reciprocals. Which one of these are you sure of the reciprocal? What's the reciprocal of tangent?
Cotangent.
Okay. In tangent's case, the reciprocal is the same as the cofunction, but only tangent. So there's 2 other trig functions. There's secant and there's cosecant. Which one goes with which?
Cosecant goes with sine.
No. Oh, excuse me. My apologies. I was hearing what you said, but I didn't pay any attention to it. Which leaves secant to go with cosine. Okay? So, no, we didn't really have to memorize anything there. The only thing we had to memorize is that the first letters are opposite, or they're different. If you find yourself putting the secant with the sine, you know you've made a mistake because you got 2 S's. You with me?
Yeah.
Okay. So you tell me the other 3. What is cosecant equal to?
That'd be 1 over sine.
What is secant equal to?
One over cosine.
And what is cotangent equal to?
1 over tangent.
You have to know these 6. Now, you just saw that you don't have to memorize hardly anything. Certainly the next 3, you don't have to memorize those a bit. You always know those as long as you know these 3. The only problem with these 3 can be getting the cosecant and secant mixed up. So as long as you remember that that first letter is different, you're never going to make that mistake. So memorizing these 6 reciprocals is really a piece of cake. Let's go on. There's 2 quotient ones you have to memorize. There are 6 reciprocals. There are 2 quotient ones. First one, only one you really have to memorize, is that one. What is tangent equal to? In terms of a quotient of 2 other things. Sine over cosine. Okay? That's a biggie. You got to memorize that. But they also want you to know what cotangent's equal to. I don't have to memorize this one. If I know the first one, I know what cotangent is. What's cotangent?
Cosine over sine.
Okay. There's another case where we've memorized 2 of them with only memorizing 1. And finally, you've got the 3 Pythagorean, making there 11 total. You got 6 reciprocal, 2 quotient, and 3 Pythagorean. Now the Pythagoreans always have squareds in them. And here's the first one. Now I'm leaving out the argument on purpose here, just so I don't have to write it over and over and over again. But there's always an argument. You cannot take a trig function of blank. You have an argument, always. What's this equal
to? 1.
Gotta memorize that one. What's this equal to?
Secant squared.
And finally, you don't have to memorize the third one. The third one is the second one, only using the cofunctions, not the reciprocals, the cofunctions. So what is the third one?
Cotangent squared theta, or squared x, plus 1 equals cosecant squared x.
Those are your 11 identities that you have to know. You really only have to memorize 5 or 6 of them. You don't have to memorize all 11 of them. Half of them you can figure out if you know the others. Okay? All right, let's go back to your questions. Let's see. I got a 3 o'clock today, so I don't have much wiggle room. All right, we did that one. Oops. So we have, they want us to turn this into something else. We don't know what, but we can certainly play around with stuff. Let me ask you, am I going to use my Pythagorean identities? Am I going to use my reciprocal identities? Or am I going to use my quotient identities?
Probably the reciprocal identities.
Or quotient.
Or quotient, yeah.
Not the Pythagorean. The Pythagorean identity requires everything to be squared. So I don't have to do that. So let's start with reciprocal identities. Let's see if we can turn this into sines and cosines. That's a good way to begin. So if we try to turn it into sines and cosines, what does secant become? Remember your reciprocal identities.
1 over cosine.
And cotangent, I don't want to use the reciprocal identity because that would put a tangent in the bottom, which doesn't do me any good. But if I try to turn that into sines and cosines, what is it?
1 over tangent.
No, it's cosine over sine.
Hold up, someone's at the door.
Zach, where's Nico, bro?
He's not here right now.
You by chance with OIS? No, he's not in it. You know when he's coming?
5-ish.
5? Crystal. That's how it is. It's like 3.
Yeah, but he has.
You don't come back for that.
I got a tutor session.
Oh, okay.
All right, I'm back.
Okay. So notice that the first thing you want to do when you're simplifying an expression, if you can, turn it into sines and cosines, because good things happen. Okay? I turn that into cosine by using the reciprocal identity, and I turn that into cosine over sine using the quotient identity. Now simplify that.
It'd be 1 over sine.
And simplify that. They don't like having trig functions in the denominator.
Be cosecant.
Correct. There you go. That's how we're going to do all of these. We're going to use those 11 basic identities to do every problem they're about to ask. Okay, which identities are we most likely to need here? Reciprocal, quotient, or Pythagorean?
Both, maybe?
I'm not going to need reciprocal. Everything we're looking at is squared. Think Pythagorean. All three Pythagorean identities involve the square of a trig function. Okay.
So the top equals 1, right?
Okay. Now, let's go back. They rarely give it to you in the way you memorize it. Notice that the way we memorize it is tangent squared of x plus 1 equals secant squared. That's the way you memorize it, but they rarely make it that simple. They give it to you in that. Well, what does that equal? If this is true down here, what's secant squared minus tangent equal?
Tangent squared x plus 1 minus tangent squared x.
Give me an answer. What is secant squared minus tangent squared? What does that equal to based on this identity? You got to do the algebra. In other words, you got to make one side look like that. Well, how do you make one side look like that?
Subtract it.
So what's the answer? What is secant squared minus tangent squared?
Secant squared minus secant squared minus 1.
Hold on. Do some algebra on this identity down here. What do I have to do to make one side of this equation look like secant squared minus tangent squared?
Oh, you just subtract tangent squared to both sides.
Okay, so what's the answer?
1.
The answer of that is 1. That's our answer. Okay? So you can see that you got no shot on these unless you have those 11 things memorized. Absolutely got to do that to begin with. Now, they get tougher on us. Well, let's draw two triangles. Remember that we're always taking trig functions of angles. So I'm going to label that angle X. Dimension it for me.
So it'd be the adjacent's 1, the hypotenuse is 2, and the opposite's 1.
Apply the Pythagorean theorem quickly to solve for that opposite side. It's the square root of the hypotenuse squared minus the other side squared.
Square root of 2 minus 1.
Square root of 3. It's the square root of 4 minus 1. In other words, one side of a right triangle is always the square root of the hypotenuse squared minus the other side squared. Everything's always squared, always. And answers are always square root of. And boy, if there's one skill a person needs in math, it's being able to solve right triangles quickly, especially with trig. More so with trig probably than geometry. Now, on this triangle over here, I'm going to make that angle y, because we know this. Dimension that triangle.
So it'd be the hypotenuse is 2 and the opposite's 1.
Okay, which makes this side square root of 3. Now, x is in a first quadrant angle. Y is a second quadrant angle. That's what they tell us. Second quadrant for y, first quadrant for x. Find the sine of x minus y. Well, no way to avoid these identities either. There's two more identities you have to memorize. And that is the cosine of sum and difference, a plus or minus b. You know what that is?
No.
Well, it's got two cosines and two sines in it. First one is cosine, cosine, opposite, minus or plus, sine, sine. Okay? The other one you have to memorize is the sine one. What is the sine of a plus, and I use plus or minus because it could be either one. Well, with the sine, I also have two cosines and two sines in my answer, but it starts out the sine of a, cosine of b, same. Not opposite, same. And the rest of it is the sine of b, cosine of a. So these two things right here, you got to memorize that. And I don't know of a really easy way to do it other than the way I just kind of described it. Okay. Now, it's crucial here because what we're looking at is the sine of x minus y. So what's that going to be? Based on our identities. We don't need this one. That's the one they teach you at first. Not sure why they do it in that order, although it makes sense to me to do it in that order. It's the second one we're going to use.
It'd be sine x cosine y minus sine y cosine x.
Perfect. Now, let's look at all of our triangles to figure out these four things. What's the sine of x? Get this triangle over here.
It's square root of 3 over 1. Or no, square root of 3 over 2.
Plus or minus?
Plus.
Because it's in the first quadrant. So, square root of 3 over 2. Now, what's the cosine of y looking at the other triangle?
Square root of 3 over 2 as well.
Plus or minus?
Minus.
Correct. So I'm multiplying it by minus square root of 3 over 2. That's this part. Now, what's the sine of y?
Be 1 over 2.
Plus,
but it'd be
minus.
Still plus.
Correct. It's in the second quadrant. Sines are plus in the second quadrant. What's cosine of x?
Also 1/2.
And also plus, because x is in the first quadrant. So, to get the sine of x minus y, now I just got to do the arithmetic. If If I do this, I get minus 3 over 4 is this part. And then I'm subtracting 1/4 from that, which is this part. Well, that's equal to minus 1. A. Now, this is about as hard as they come, at least to the people that I've taught trig to. But the basic method is pretty much the same. You draw a triangle and label one of the angles. Well, we can tell that that has to be an angle and that has to be an angle because you take trig functions of angles. So I can label a triangle, I can label x, and then I can label 2 out of the 3 sides and then the third side. And I can do that for both my triangles with x and y being different angles. But I have to know this sum and difference formula. These two things that I laid out right here, that are the two sum and difference formula. And I would say you can get away with just those two. You don't need to memorize the tangent one, perhaps. Not as important. There is a tangent one, and it's harder to memorize. But these two, the way to memorize them, let me help a little bit. Cosine. That sign there is the opposite of this sign here, notice. This is plus or minus, this is minus or plus. So when you're using the cosine sum or difference, the right side of it's always going to have the opposite sign of what you're starting with. Okay? When you use the sine one, it's not the opposite sign. It's the same sign. Whatever this sign is here, you're going to have that same sign there. That's why in our case, when it was x minus y, this middle sign was the same, minus. And then you go back to your triangles and figure out what all 4 of these things are. In other words, from the 2 triangles, I can figure out the sine of x, the cosine of y, the sine of y, and the cosine of x. Once I've figured out all those 4 numbers, now you just have some arithmetic to come up with the answer. All right. Hold on. I guess that's all I need here. Okay. This looks very, very similar, right? Almost the same thing. Only different numbers, different quadrants, and different sum and difference formula. Last time we were working with the sine of 2 different angles. This time we're going to be working with the cosine of the sum of 2 angles. So what's my first step? Always remember when I say what's the first step in trig, it's almost always
Draw the triangle.
okay. And it really should be draw a right triangle, because it has to be a right triangle. And do what? I got to do one more thing. Got to label the angle, because x could be the upper one. So I got to label what angle I'm talking about. Over here, I'm going to draw a different triangle. I got to label that angle, and that angle is y. Forget about what quadrants they're in for the moment. Label the triangle on the left.
The opposite sides 3, the hypotenuse is 1.
That's never true. I know what you meant to say. The opposite side is 1 and the hypotenuse is 3.
Oh, yeah.
Always remember the hypotenuse has to be the longest side of that triangle. What's the third side?
Square root of
Excuse me.
2.
Square root of 8, right?
8.
I mean, it's the square root of 3 squared minus 1 squared. So it's the square root of 8. Now, whether you reduce that or not, I don't really care. I don't think it matters very much. We're just going to leave it square root of 8 and not worry about simplifying it into perfect format. Okay, and you'll see why. Now let's look at this other triangle. Cosine of y is 1/3. Dimension that for me. Based on that.
So it'd be the hypotenuse is 3 and the adjacent's 1.
What's the side opposite y?
Square root of 8 still.
Okay, cool. Now, we're ready to go, only we need that identity. So what is the cosine of x plus y equal to? Remember, your answer has 2 cosines at the beginning and then 2 sines at the end. That's the easiest way to memorize it for me. So what must it look like? If there's 2 cosines at the beginning and 2 sines at the end, then what's the sign in between going to be? Plus or minus?
It's going to be minus.
Okay, good. What are the 2 cosines at the beginning?
Cosine x, cosine y, minus sine x, sine y.
See, once you figure out a pattern, it's not really that hard to memorize them. Okay, now we can figure out all 4 of these numbers. Tell me what the cosine of x is.
Cosine of x would be 1 over, or wait, 8, or square root of 8 over 3.
It's cosine of y.
1 over 3.
What are the plus or minus signs of both of those? And why? What quadrant are both x and y in?
1, so they're all positive, but you have the negative sign there.
Exactly. I don't have a negative sign there.
Or you have the minus 10.
That's subtraction. That's not a negative sign. That is subtraction. Okay.
So it'd be minus
Subtract,
1/3.
what's the sine of x?
1/3.
What's the sine of y?
Square root of 8 over 3.
Now, what's that give us? Square root
0.
of 8 over 9 minus square root of 8 over 9. And that's why I didn't bother to reduce the square root of 8, because sometimes nice things happen and you don't need to ever do it. So, yeah, 0 is the answer. So it's all about the triangles to get the numbers. Then it's about the quadrants to get the signs. And then it's about the trig identity to turn sum and difference into 4 different things. Zach, gotta go. Hold on a minute. Let me just check my calendar. We are doing tomorrow at 11:50. I can do earlier if you prefer. It's not going to matter to me. 11:30?
I get out of my class at 11:30, so we could do like 11:40.
Excuse me, hold on. Let's do 11:45.
Okay.
We'll cut the difference here. We'll do 11:45 to 12:45. All right. I will talk to you tomorrow.
Okay.
All right, Zach.